And we're back. Okay, so here's the warm-up. If you're playing along at home, go ahead and do these two problems by Desmos. I've actually got the second one still up from first period. So again, just plug it in. Negative 2x minus 1 is equal to y. You don't even have to solve for y. I've got x plus y is equal to 3 and for my second one. So I'm just going to screen capture that in so that I have it for the next class as well. Current page. There we go. And let me jump back here. There we go. So it looks like, I didn't get it with the point on there. That's okay, though. The point is negative 4 comma 7, right? Negative 4 comma 7. So that's my solution. Negative 4 comma 7. Okay. Taking a look at number 5. Just redoing this one for number 5 here. Oops. All right. So y is equal to 1/2 x. I'm going to go over here. I'm going to replace this for y is equal to 1/2 x. Remember to move to the right with the right arrow key when doing a fraction. And y is equal to negative x plus 3. And then there's my coordinate, 2 comma 1. I hope you guys would all agree that solving using Desmos is really convenient. I'm really surprised that the state allows you to use this on the end of course test. But they do, and that's awesome. Take advantage of it. So we've got 2 comma 1 and negative 4 comma 7. Okay. Again, the keys are in the binders for the graphing problems, but I hope, do I need to go over any of those?
No.
I hope not. Because honestly, they're quite easy when using Desmos. Quite easy when using it. Just plug it into Desmos and then solve. Now, I hope you guys saw for number 4 on each side that they didn't come out nice. And when you're graphing by hand and it doesn't come out nice, meaning come out at a nice clean cross point, if you're graphing by hand and it does not come out nice, what you have to do then is switch methods. Okay? And I'm assuming that we don't have the use of technology. Like if you can graph using Desmos, then graph using Desmos. Don't even try it by hand. Now, if you're graphing and it doesn't come out, graphing by hand and it doesn't come out nice, we've got to switch methods. We've got to have a more algebraic method. So we can all put our computers away now. So let's solve systems in different methods now. Solve systems in different methods. We're going to learn 2 algebraic methods for solving systems of equations. 2 algebraic methods. And we're going to learn them in section 5.2 and 5.3. Now we're going to spend 2 days on each. Friday, Monday for section 5.2. Tuesday, Wednesday for section 5.3. Review Thursday. Quiz 1 week from today, Friday. Okay? And again, let me remind you, that is the last chance to bring up your grade. Did I hand out this half sheet yet?
No.
I keep forgetting in my morning classes. So let me do this right now while it's on the video too, just in case anybody that's been stuck at home will know it too. We all see my tree over here, right? Did I explain this yet?
No. Yeah.
Kind of? Yeah. So this is the real parameters here. The direction. You could get an opportunity of having 5 bonus points. I know. I'm generous. Shh, quiet, please. You have the opportunity of getting 5 bonus points if you create a somehow math-related ornament. You can relate it to math in any way that you need, but I need a paragraph explaining how it relates to math. The reason I have you write the paragraph is so you can't draw 1 plus 1 on a piece of paper and stick it on the tree and be like, where's my bonus points? I need you to actually put some thought into it, okay? So, you get 5 bonus points for making a math-related ornament, writing a paragraph for it. It's got to be at least 100 words in the paragraph. Don't freak out. This is 100 words, people. I made it so that this little half sheet has 100 words on it.
Exactly.
I think it's like 103 or something like that. I don't know. You don't need to count. But it's about 100 words. But people are always like, "Oh my gosh, that's like 2 pages." No, your estimation skills are very bad. This is 100 words. Okay, a half sheet of paper, and this even like size 14 font. So just write up a little bit about how your topic relates to math, and then have it turned into me. I wrote December 13th here. I'd like them by next Friday, so that we can enjoy them the full exam week. But if you have them to me by the following Monday, the Monday of exam week, that would be fine. Yeah, question.
So like if you made 10 of them, could you get 50?
No, one ornament per person. Sorry.
It'd be like cardboard paper.
Yeah, it could be whatever, however you want to construct it, however you want to make it.
And do you have
And
to have like
it could be any sort of decoration.
the hook on?
Like somebody was like, "Can I make a star for the tree?" Sure. Can I make? Some people, past years, made like presents underneath the tree and talked about how they were the different shapes, like a prism and cylinder and whatever. Okay. So you do whatever you want. You be creative, but it's 5 bonus points. Again, it's completely optional. I'm really doing this because I'm still getting emails from parents saying, "How does my kid bring up their grade?" And it's like, if your kid doesn't know how to bring up their grade, they're going to sleep in my class. No, he knows. He knows, and his parents know too. Me and his parents, we've talked plenty of times. They know. But if you would like to do this, you can. I'm just giving you the opportunity to pull up your grade a little bit more. I think we would all agree. I've provided a lot of possibilities of bringing up your grade. Yes.
Why is there a Starbucks thing? Because it's really bothering.
I don't know. Somebody just threw that up there.
Yeah,
That's
that's
not
really-
an actual bonus.
Yeah, that's really bothering.
You had a couple typos.
Starbucks. Star on the tree. I thought that was funny. So I thought that.
No.
What's my typo?
Christmas.
Christmas.
No,
Christmas. See what I did? Christmas.
Christmas.
I counted
Christmas
100
science.
words.
Yeah,
I counted 98
Christmas.
words on this page.
Right?
Did you count the Merry Christmas?
I counted.
I counted 100.
There you go. There's 100.
Okay.
I counted exactly
Yeah,
100.
Christmas.
Counted
All right.
Chris and Matt.
So there's your opportunity there. You can take advantage of it or not. It's completely up to you. So let me hand out the guided notes then. Again, that's due next Friday. But honestly, if you got it to me by the following Monday, that would be fine as well. So I just got done talking about how if you were trying to graph and the graph was not coming out at a nice clean point, what you would have to do is use some other algebraic method. The first method that we're going to talk about, first algebraic method that we're going to talk about is called substitution. Now think about that word substitute. Like, the first thing that you guys come to think about is substitute teacher, right? What is a substitute teacher? A substitute teacher is when a teacher is out and they put someone in their place, right? Someone comes in that person's place. Think about other times we use the word substitute. Like, I think about that fake Whopper that they got, like that vegetable patty
Impossible
Whopper,
burger.
right? What's it
Like
called?
the Impossible.
Impossible, yeah, like the Impossible Whopper, right? That is a meat substitute, right? They take the meat out of the burger, they put something, I don't know,
It's like tofu.
tofu, I guess, I don't know.
Chicken something.
They put something in its place that is almost equivalent, right? I don't want to say almost equivalent. I don't know. I don't need those things.
Tofu.
I don't know.
Tofu?
I don't know. Some people eat it. I get it.
Yeah, I
But
did
anyway,
all the time.
what I'm getting at here is they substitute in something equivalent in its place, something that will, in terms of cooking, work the same way, and they use that in its place. That is called a substitute, and that's generally what we are going to be doing here when solving these systems by substitution. We're going to be inputting something equivalent in something else's place. Now, I'm going to talk through the steps, but honestly, this is one of those things that you have to kind of do to understand. But let me talk through the steps, just in case you are one of those people that like the directions. First step: solve one of the equations for one of the variables. And honestly, this is done for you a lot of the times. If you ever have a system that has one equation that's already solved for, like look at A and B down at your papers. Do you notice how in A, both of them are set equal to y?
Mhm.
You notice how in B, one of them is set equal to y? That's step one. So in examples A and B, that's done for you. Step two, substitute the expression that's solved for into the other equation and solve that equation. So into the other equation, I'm going to take out the variable, and in its place, I'm going to put something equivalent, and I'm going to solve that equation. I should create myself an equation with only one variable in it, so I could get x equals or y equals a number. In the end of step two, you should have half your answer. And then by the end of step three, you should have your full answer. You take that x equals or y equals a number and just plug it back into one of the original equations and solve for the other coordinate. Let me remind you that the end goal of all of this is to figure out where the two lines will cross. That's what you're looking for, right? That's the end goal of solving a system. It's the coordinate where the two lines will cross. That's your end result. That's your end goal. By the end of step two, you should have one of the two coordinates. By the end of step three, you should have the other coordinate. So let's try it. Solve the system by substitution. And again, you have to pay attention to the directions. If this just had said solve the system, you can do whatever you want. You could graph, you could substitute, you could eliminate. If you had your computer, if you had technology, if you were allowed technology, you could use Desmos. Like if they just said solve the system on your state test, and you got that Desmos button, you click that Desmos button and you put this right into your graphing calculator, and you click on that intersection point. It's done for you. But this says solve by substitution. So what I'm going to do here is look at my two equations. I've got y equals 3x, right? Now, I can say that y is equivalent to 3x. So I'm going to take this 3x, and in the other equation, I'm going to remove y, and in its place, write something equivalent. Well, what is equivalent to y? 3x. So that's going to go in its place. It was y is equal to x minus 2. And so I'm going to, in y's place, write 3x. So it's 3x equals x minus 2. And look what I've created. I've created an equation that only has x in it. Let's subtract x over to the other side. Get rid of the little guy. And divide by 2. Okay, I'm at the end of step 2. Step 1 was already done for us. But I am at the end of step 2 now. By the end of step 2, you should have one of the two coordinates, x or y. So we have x here. It's -1 comma something. And I like to go ahead and start my answer. Like on the quiz next Friday, I would suggest that you go to your answer blank. As soon as you've got one of your two coordinates, x or y, start making your coordinate pair. Now, at this point, I can go into either of the two equations and plug in my -1. So let's just go to the top equation. It doesn't matter. It was y is equal to 3x. And so now I'm going to say 3 times -1 because I know what x is now. So y is equal to 3 times -1, which is -3. X is -1, y is -3, and I'm done. That's the location. If I were to graph it, I would see that they cross at -1, -3. If I were to put it into Desmos, I click on that point, it would be -1, -3. This is just an algebraic method to do so. Yes, sir.
So how does that make like a messy equation? How does that turn it into something standard like that?
I don't know what you mean.
Okay.
You know how you said it was already solved for us?
Yeah?
How is it like unsolved?
Let me show you.
Yeah, there you go.
I'm gonna increasingly make it a little bit more weird. Like so, this next one. Do you notice how the second equation is not solved for y, right? In the first example, both equations were solved for y, so I essentially just set them equal to one another. In this second example, I have y is equal to x plus 1, right? So perfect. My step 1 out of those 3 steps at the top of the page, that's done. One of the equations is already solved for one of the variables. So I'm going to take my y is equal to x plus 1. And in the second equation, plug x plus 1 in for y, because y is equivalent with x plus 1. I'm going to remove y and substitute in x plus 1. So here's my second equation. Now watch here. I'm going to do this from time to time, but you don't have to do this on your page. I'm just showing you what this principle really is. That was my original second equation, right? 4x plus y is equal to 6. So what I'm going to do is I'm going to remove y, and in its place, write the equivalent statement to x plus 1. And now I can solve this equation. Remember, this is my new piece in there. That was y, right? But I took the meat out, I put in the tofu, whatever that is. I took the y out, I put in the x plus 1, and now I create something equivalent. So 4x plus x, that's 5x. I subtract 1 from both sides. And then I divide by 5. See, once we get to this point, it's just solving an equation. It's back to chapter 1. Now, that's half my answer. I go to my answer blank. I wrote 1 comma something. And now I have to plug in 1 back into one of my original 2 equations. Well, I think you guys would agree with me that the top equation looks a little bit more simple than the bottom equation. So I'm going to go into the top equation. Y is equal to x plus 1. That's my original top. So I'm going to go say y is equal to 1 plus 1, which is 2. So my full coordinate where these two lines cross is 1 comma 2. See, it's anomaly. Temperature should be going down, but it's actually going up a little bit. Correlation, not causation. All right, let's keep it going. Let's take a look at example C. Now, I'm continually making this a little bit more weird, right? Are either of these 2 equations solved for? No. So I have to do step 1 in this case. This is my first example where I must do step 1. What's the easiest variable to solve for, and which equation is it in? What's the easiest variable to solve for, and which equation is it in?
It's easier to solve for x.
Which equation, top or bottom?
Top.
Top. X in the top. Out of my 4 options, and yes, I have 4 options, I could solve for x in the top, y in the top, or x in the bottom, or y in the bottom. Out of my 4 options, x in the top is the easiest to solve for. Why? Because it's alone. Right. Because it's alone. It does not have a number in front of it. It does not have a coefficient. Could I have solved for y in the top? Sure, but that's going to give you some weird, messy fractions, and I would hesitate to do that. Could I solve for x or y in the bottom? Yeah, but that's going to give me some weird fractions, and it's going to throw you guys off. I'm just trying to make the easiest route possible for you. So here's what I do. I'm going to use this notation again where I number the equations. I'm going to take equation 1 where it says x plus 6y is equal to 11. And I am going to solve for x. How do I solve for x? Minus 6y? Is that what you were going to say? So minus 6y. Now, do I even need to put it in any sort of order? No. Like we all got stuck into like this, y equals mode. Like we always solve for y. That's not the case anymore. That was the case when we had to graph, but we're not graphing now. Okay, I've got x is equal to 11 minus 6y. So now I've created that equation where I have x equals. So I'm going here, and I say 11 minus 6y is going to go right in here. X is equivalent with 11 minus 6y. See, I manipulated equation 1. So I'm going to go into equation 2 and plug it in. I'm going to go into equation 2 and plug it in. So that's going to give me, again, I'm going to write it like this for right now. 2x plus 3y is equal to negative 5. See, what am I removing out of that equation? Just the x. Not the 2, just the x. I remove the x, and in its place, write something equivalent. 11 minus 6y. And notice that I put this in parentheses. If you ever have a number out in front of the variable, you have to put what you're inputting in parentheses, because you have to remember to distribute that out. Now, the reason I wrote it off to the right is because it's going to take a couple more steps than usual to solve. 22 minus 12y when I distribute. I combine like terms. I get negative 9y. Don't say minus 15y. Now I can start solving. We subtract the 22. Negative 9y is equal to negative 27. And we divide by negative 9. So y is 3. Again, that's halfway to my answer. Now, I've done the heavy lifting so far. Like, I've done the hard part. All I need to do now is just go back in and figure out what my x value is. Okay, take a look at this manipulated equation that we started out with. It's x equals, isn't it? So let's just go back into that equation and plug in y. 11 minus 6 times 3.
11 minus 18.
Which is?
Negative 7.
Negative 7. So we've already done the hard part. The hard part was figuring out the first coordinate. That was the hard part. Kind of like, you're playing with dominoes. As soon as you figure out the first domino, the other ones fall. As soon as you figure out the first variable, the other one's not so bad. Okay, whenever you're done copying that one down, flip it over on the back. Do the top one on the back. Very similar to this one. Because in this case, this is one of the hardest types of substitution problems. When you have to solve for one of the variables. Gio.
Can you keep this problem up just for an example? While we're doing these, the ones on the back. Or were you gonna do this one with us?
Yeah, we're gonna do this one with you guys. Yeah, we're gonna do this
Right,
together. Don't worry. I'm gonna walk you through this one too. Don't worry. Okay, so let's do this one now. What variable and in which equation is the easiest one to solve for? Anna? Good. Y in the top. Because again, it's alone. So let's take the first equation and manipulate the first equation. Negative 2x plus y is equal to 8. Again, I just rewrote it out of the top. How do I solve for y? How do I get y alone? Add the 2x. So that gets me y is equal to 8 plus 2x. Do I need to say 2x plus 8? No. We're not graphing here. You can. That's what we're trying. Now I go to my second equation. Here was my second equation. 3x plus 2 times y, going to leave a little room, equals 9. Because now I take out y, I plug in its substitute. 8 plus 2x. And now I've created an equation with only x's in it. So I can solve that equation. Distribute the 2. Three x and 4x makes 7x. Negative 7?
Right here. You get negative 7 after you do that.
Oh, I see what you're saying. So 7x is equal to negative 7, which means x is negative 1. I go to my answer blank, and I start with the negative 1. And now all I need to do is take that negative 1 and plug it into my equation. And I'm going to go back here. This y equals 8 plus 2x. Y equals 8 plus 2 times negative 1. So 8 minus 2 is 6. Negative 1, comma 6.
I think that way is easier, like getting y by itself. Or
Well, it all depends. Like, the reason we got y by itself is because it was alone.
Yeah, I'm saying, but like that one's easier. It takes. I feel like it takes like that one's easier than if you flip them. And you got the x or the y first.
As Michelle Walker would say, it's like a puzzle.
But
Yeah,
like,
that's
true.
you can't get like the other equation until you get the first equation.
I know.
So,
That's what I'm saying, it's a puzzle.
yeah, but like that's the only way to do it. Like you can't get that.
Yeah, I hate it.
I was explaining to Noah.
I know, I was-
He was telling me.
You know
It's still
what?
like a puzzle, though, so.
The wise words of the sage.
Cable television provider.
Okay, one cable TV provider has a $60 setup fee and an $80 per month fee. Another one has a $160 equipment fee and $70 per month. How many months will the cost be the same? Now, we've done problems like this before, but we really didn't understand that what we were doing in substitution. So I want to talk it through in terms of a system. Because on the state test, you might have to write out a system of equations. Like I've seen it before where it says, write a system of equations to represent this situation. And it gives you the two boxes where you have to put in the two equations. Here's what I mean. Let's write an equation for each situation, for each company. $60 setup fee, $80 per month. Y equals 60 plus 80x. 60 plus 80x, quite simple. Second provider, $160 equipment fee, but they only cost $70 per month. So the second company is cheaper per month,
Startup fee is.
but the startup fee is $100 more.
Yeah, that's not good.
So if you're going for the long run,
Go for a second.
Which is where the second question, part B, will come into play. But let's figure out what that threshold is. At some point, they're going to cost the same amount. Let's see what that threshold is. Now, understand that what we were doing, like before, we would have just set these equal to one another to see when they were the same. But what we were really doing back then is substitution. I'm going to take 60 plus 80x, and I'm going to plug it in for y into the second equation, which essentially just...
you just didn't tell us that it was something.
Right, we just knew that we were creating an equation. 160 plus 70x. We get rid of the little guy of 70. So it's 60 plus 10x is equal to 160 plus nothing. I don't know why I wrote a plus. We subtract the 60. So 10x is equal to 100.
Is it always gonna be that easy? Cause like
Is
That
it
one you
always
just-
going to be that?
that
way?
one you could have solved like without even writing it out.
Not always. And we'll see more when we get to section
Because
5.
It would take 10 months, right?
10 months.
So it won't be that easy.
Not always. So we say 10 months. Now, it also asks me, what will that cost be? How do I figure that out? What's that? 60 times 10. No, not 60 times 10.
No, it'd be y equals 60 plus 80 times 10.
Good. 60 plus 80 times 10.
Are we still writing the answer as like a coordinate?
In this case, because there's context to it, I'm going to write it like as a statement. So this is y is equal to 60 plus 80 times 10. as we expected. 60 plus 80 times 10, that's 800 plus 60, which is 860. So here is my final answer. 10 months, $860. That's my answer. See, when we're given a word problem, we don't really want to give the answer back as a coordinate because we weren't given a system. We created the system to solve the problem. Now, part B to this says, okay, if I was only sticking around for, how many months does it say?
6 months.
6 months.
The first one.
We say the first one, right? Let's actually look at the system and see why. Y is equal to 60 plus 80x, and y is equal to 160 plus 70x. If it's 6 months, obviously my starting amount is going to outweigh the benefit of the lower price per month, right? It's going to be $100 extra just to start up, and I'm not going to recoup that cost yet over the course of 10 months. But in what we should really do is say this: y is equal to 60 plus 80 times 6. Well, that for $540. And this is going to be y is equal to 160 plus 70 times 6, 420, 580. So we could even go so far as to say, how much cheaper is it over the course of 6 months? $40 for the first option, right? You're saving yourself $40.
But couldn't you just do the 100 minus 40? Because
But you're not really saving yourself $100.
I know I'm saying because the x's they're 10s and if you could just go by 10.
That's true in this case.
And I'm saying 100 as 10 months, like that'd be like fine.
Yeah. Yeah.
I have a raise.
I see what you're saying. Okay. Your homework for tonight. Oh man, the bell's gonna ring in like 1 minute. Your homework for tonight, page 255, 7 to 11, 13, 14. There you go. Bye.
What on the notebook?
Hola.